Imagine this. You are in a turbine hall, underground, deep beneath a hydroelectric dam. The machines around you are massive. Each turbine weighs 2,000 tons. They spin at high speed, generating electricity. You hear a sound, a vibration, growing louder. You have heard it before. For years, everyone has. The turbine shakes. It rattles. Engineers say it needs repairs, but the plant keeps running. Production quotas must be met. And then the vibration becomes a roar. Metal screams, bolts shear. The turbine breaks free from its foundation. It explodes. A 2,000-ton assembly disintegrates. The turbine cover, a massive steel disc, flies 100 feet into the air like a bottle cap. And then, water. A wall of water erupts from the destroyed turbine shaft. The reservoir floods the hall, billions of gallons. You try to run. The water is faster. It fills the room in seconds. You drown in darkness. 75 workers gone. And the turbine had been warning everyone for years. August 17th, 2009. The Sayano-Shushenskaya Dam, Khakassia Republic, Siberia, Russia, on the Yenisei River. One of the largest hydroelectric plants in the world. 10 turbines, 6,400 megawatts of power. The plant supplies electricity to aluminum smelters across Siberia. It is critical infrastructure. And it is falling apart. Soviet-era equipment, built in the 1970s and 80s. Decades of deferred maintenance. Turbine 2 has been vibrating excessively for years. Maintenance logs document the problem. Engineers recommend repairs. Management delays. The turbine keeps running until it cannot. This is the story of the Sayano-Shushenskaya Dam disaster. The Soviet legacy of cutting corners. The warnings ignored for profit. The catastrophic turbine explosion. And the 75 workers who drowned in the place they thought was safe. The Sayano-Shushenskaya Dam was conceived during the height of Soviet industrial ambition, the 1950s and 60s. The Soviet Union was racing to modernize, to prove communism could outproduce capitalism. Massive infrastructure projects were launched. Dams, power plants, canals. The goal was electrification, powering factories, smelters, cities. The Yenisei River in Siberia was identified as ideal for a major hydroelectric project. The river is one of the largest in the world, high volume, strong flow, perfect for power generation. Planning began in the early 1960s. The dam would be located near the town of Sayanogorsk, a remote area, harsh climate. Winters reached -40 degrees, but the location was perfect. The river narrowed at this point, a natural spot for a dam. The project was approved. Construction began in 1968. The Sayano-Shushenskaya Dam was designed as an arch gravity dam, 242 meters high, over 1 kilometer wide, one of the tallest dams in the world. The reservoir behind it would hold 31 billion cubic meters of water. The power station would have 10 turbines, each capable of generating 640 megawatts. Total capacity over 6,000 megawatts, enough to power entire regions. Construction took over a decade. Thousands of workers labored in brutal conditions. The Siberian winter made work dangerous. The summer brought floods. Workers lived in temporary camps. Conditions were harsh, but the project moved forward. The Soviet system prioritized results. Safety and worker welfare were secondary. Deaths during construction were common. Exact numbers were not publicized, but estimates suggest dozens of workers died. Accidents, exposure, equipment failures. The Soviet Union did not dwell on casualties. The project mattered more than individual lives. The first turbine came online in 1978. The remaining turbines were installed over the following years. The last turbine was completed in 2000. The dam became fully operational. It was a source of pride, a symbol of Soviet engineering prowess. the largest power station in Russia, and it supplied electricity to some of the world's largest aluminum smelters. The smelters required massive amounts of power. Sayano-Shushenskaya provided it. But from the beginning, there were problems. The turbines were massive, complex. They required constant maintenance. Bearings needed replacement. Seals wore out. Bolts loosened from vibration. In a well-maintained plant, these issues are managed. Regular inspections, scheduled downtime for repairs. But in the post-Soviet era, maintenance budgets were slashed. The Soviet Union collapsed in 1991. The Russian economy entered chaos. Infrastructure funding dried up. Power plants were privatized or semi-privatized. The focus shifted from reliability to profit. Maintenance was expensive. Shutting down turbines for repairs meant lost revenue, so repairs were deferred. Problems accumulated. By the 2000s, the Sayano-Shushenskaya plant was aging. The turbines had been running for decades. Some components were original, 40 years old. Metal fatigue was inevitable. Vibration was increasing. Workers noticed. Engineers noticed. Maintenance logs documented excessive vibration in several turbines. Turbine 2 was the worst. It shook noticeably. The vibration transmitted through the structure. Workers could feel it. But shutting down Turbine 2 for major repairs would take months. It would cost millions, and it would reduce power output. Management decided to keep it running. Vibration monitors were installed. Limits were set. But the limits were routinely exceeded, and nothing was done. The construction of Sayano-Shushenskaya Dam was a monumental Soviet engineering project. An arch-gravity design required massive concrete pours, thousands of cubic meters. The concrete had to cure properly. In Siberian winters, this was challenging. Concrete can crack if it freezes before curing. Heating systems were used, temporary enclosures, but quality control was inconsistent. Some sections of the dam have minor defects, cracks, voids, not enough to compromise the structure, but evidence of rushed construction. The turbine hall was excavated deep into bedrock beneath the dam, a massive underground chamber, 100 meters long, 20 meters high. This is where the 10 turbines would be installed. Each turbine is a vertical assembly. Water from the reservoir flows down through penstocks, massive pipes, and enters the turbine from above. The water spins the turbine blades. The turbine shaft is connected to a generator. The spinning motion generates electricity. After passing through the turbine, the water exits through a draft tube into the river downstream. Each turbine assembly weighs over 2,000 tons. Installing it required precision. The turbine is mounted on a massive concrete foundation. Anchor bolts secure it. These bolts are critical. They hold the turbine in place against enormous forces: the water pressure, the rotational force, the vibration. If the bolts fail, the turbine can break free. The consequences are catastrophic. The turbines at Sayano-Shushenskaya were manufactured by Soviet factories: Leningrad Metal Works, Kharkov Turbine Works. The manufacturing quality varied. Some turbines were excellent, others had flaws. Machining tolerances were not always perfect. Balancing was sometimes off. An unbalanced turbine vibrates. The vibration accelerates wear. Over time, it can cause failure. Turbine 2 was installed in the early 1980s. It began operation in 1985. For the first decade, it operated normally, but by the late 1990s, vibration was increasing. Inspections revealed wear on bearings. The turbine shaft alignment was shifting. This is not unusual for aging equipment, but it requires correction. Bearings should be replaced, alignment should be adjusted, the turbine should be rebalanced. These are standard maintenance procedures, but they require shutting down the turbine, and in the 2000s, that was seen as unacceptable. The plant was under pressure to maximize output. Electricity demand was high. Aluminum smelters in the region consumed enormous power. If Sayano-Shushenskaya reduced output, the smelters would suffer. Production would drop. Revenue would fall. The economic pressure was intense. Plant management made a decision: keep the turbines running. Monitor the vibration. If it gets too high, then shut down. But what is too high? The threshold kept being raised. Vibration that would have triggered a shutdown in the 1980s was tolerated in the 2000s. The logic was flawed, but profit-driven. By 2009, Turbine 2 was in bad shape. Maintenance logs showed vibration levels far exceeding design limits. Engineers recommended a full overhaul, disassemble the turbine, replace worn components, rebalance, realign. Estimated cost, several $1 million. Estimated downtime, 3 to 6 months. Management declined. The turbine stayed online. Vibration monitors alarmed regularly. Operators acknowledged the alarms and did nothing. The turbine continued spinning, shaking, wearing, heading for failure. August 17th, 2009. Early morning. The Sayano-Shushenskaya plant is operating at full capacity. All 10 turbines are running, generating over 6,000 megawatts. The turbine hall is staffed, 75 workers on shift, engineers, technicians, operators, maintenance crew. Some are in the control room monitoring systems. Others are in the turbine hall conducting inspections. Routine work. The plant has been running for decades. Everyone knows the sounds. The hum of generators, the rush of water, the vibration, especially the vibration from Turbine 2. At 7:13 a.m., operators in the control room notice Turbine 2's vibration is increasing. This is not unusual. It happens regularly. They watch the monitors. The vibration climbs. It exceeds normal limits, but it has done this before. Operators have procedures. If vibration reaches critical levels, they can reduce power output, slow the turbine. That usually stabilizes it. They prepare to adjust, but the vibration does not stabilize. It accelerates. The monitors show levels never recorded before. The turbine is shaking violently. Operators try to reduce power. The turbine does not respond. Something is wrong. They initiate emergency shutdown procedures. But turbines do not stop instantly. They take time to spin down. Turbine 2 does not have time. At 7:13 and 12 seconds, the anchor bolts holding Turbine 2 fail. Metal fatigue. Decades of vibration. The bolts shear. The entire 2,000-ton turbine assembly breaks free from its foundation. It is still spinning at high speed, and it is no longer secured. The turbine begins to shake violently. The mounting structure disintegrates, and then the turbine explodes. The turbine cover, a massive steel disc weighing over 100 tons, is blown off. It flies upward, 100 feet into the air. It crashes through the turbine hall ceiling. Concrete and steel debris rain down. The turbine blades disintegrate. Metal fragments become shrapnel. They tear through equipment, through walls, through anything in their path. And then the water comes. With the turbine destroyed, the penstock, the pipe feeding the turbine, is now an open hole. Water from the reservoir pours through, billions of gallons under enormous pressure. The water erupts into the turbine hall like a geyser, a wall of water, moving at incredible speed. The hall begins to flood. Workers in the turbine hall have seconds. Some are near exits. They run. They make it out. Others are deeper in the hall, near Turbine 2. They see the water coming. They try to run. The water is faster. It hits them, sweeps them away, drowns them. Some are crushed by debris. The turbine hall is a chaos of water, metal, and concrete. The lights go out. Emergency systems activate. Alarms blare. But 75 workers are inside. In the control room, operators watch in horror. Their monitors show catastrophic failure. Turbine 2 is destroyed. Water is flooding the hall. They sound evacuation alarms. They call for emergency services. They try to account for personnel. But communication is failing. The flooding has damaged electrical systems. Phone lines are down. Radios are not reaching everyone. Outside the plant, the explosion is visible. The turbine cover that flew into the air crashes back down. It lands in the reservoir, a massive splash. Witnesses see water erupting from the plant, a geyser shooting into the air. Something catastrophic has happened. Emergency services are called. Ambulances, fire trucks, rescue teams. They race to the plant. but they do not yet know the scale of the disaster. Inside the turbine hall, the flooding continues. The water from the reservoir pours through the destroyed Turbine Two shaft. The hall fills. Workers who survived the initial explosion are now trapped. Some find air pockets, small spaces where the ceiling is higher. They cling to equipment, to railings, waiting for rescue. Others are swept into the flooded sections. They drown. The water is cold, fast, unforgiving. Rescue teams arrive. They enter the plant. They find chaos, water everywhere, debris, darkness. They search for survivors. They find some, workers who made it to exits, who climbed to higher ground, injured but alive. The rescuers keep searching, but large sections of the turbine hall are completely flooded, unreachable. They cannot get to everyone. The plant's emergency systems activate valves to stop water flow to Turbine 2, but it takes time. The penstock is massive. The water pressure is enormous. Minutes pass before the flow stops. By then, the turbine hall has flooded extensively. When the water finally stops, the rescue teams can enter flooded areas. They find bodies, workers who drowned, workers crushed by debris. The recovery effort begins. Over the following days, the full toll emerges. 75 workers were in the plant when Turbine 2 exploded. 75 did not survive. Some bodies are recovered immediately. Others take days. Some are found in the wreckage of the turbine hall. Others were swept into flooded penstocks and tunnels. The recovery is difficult, dangerous, but eventually, all 75 are accounted for. There was no completion for Sayano-Shushenskaya as it was. The plant was destroyed. Turbine 2 was obliterated. The turbine hall was flooded and severely damaged. Other turbines were offline. The entire plant was shut down. Russia lost 6,000 megawatts of generating capacity overnight. Aluminum smelters in the region faced power shortages. The economic impact was immediate. Investigations began. Russian authorities launched inquiries. Prosecutors examined maintenance records. Engineers analyzed the wreckage, and the truth emerged. The disaster was preventable. Turbine 2 had been deteriorating for years. Vibration logs showed escalating problems. Engineers had recommended repairs. Management had ignored them. The anchor bolts that failed were original, 40 years old. They had never been replaced. Metal fatigue was inevitable, but maintenance was deferred. Profit was prioritized over safety. Criminal charges were filed. Plant management, safety officers, maintenance supervisors. They were charged with negligence, with violating safety regulations. The trials were public. The evidence was damning. Maintenance records, vibration logs, repair recommendations that were ignored. Prosecutors argued that 75 workers died because management chose profit over safety. The defendants claimed they were under pressure to meet production quotas, that shutting down turbines was economically unacceptable. The court was not sympathetic. Convictions followed. Several managers received prison sentences. Others were fined. The Rus Hydro Company, which operated the plant, faced massive lawsuits. Families of the 75 workers sued. Settlements were reached. Millions of rubles paid, but no amount of money brings back the dead. The Russian government ordered a full audit of all hydroelectric plants. The Sayano-Shushenskaya disaster exposed systemic problems: deferred maintenance, aging Soviet-era equipment, inadequate safety culture. Other plants were found to have similar issues: vibration, worn components, delayed repairs. A nationwide upgrade program was initiated, billions of rubles allocated, but the damage to public trust was done. Reconstruction of Sayano-Shushenskaya began in 2010. The destroyed turbine hall was rebuilt. New turbines were installed, modern equipment, better safety systems. The project took 4 years. In 2014, the plant resumed full operation. It now generates electricity again, but it is not the same. The 75 workers are gone. Their names are on a memorial at the plant, a reminder of the cost of negligence. The Sayano-Shushenskaya disaster changed how Russia manages critical infrastructure. Before 2009, maintenance was often deferred. Economic pressure outweighed safety concerns. Sayano-Shushenskaya forced a reckoning. The disaster proved that ignoring maintenance does not save money. It costs lives, and it destroys infrastructure. New regulations were implemented: mandatory inspections, strict vibration limits, equipment replacement schedules. Hydroelectric plants across Russia were audited. Turbines were overhauled. Anchor bolts were replaced. Safety systems were upgraded. The goal was to ensure no other plant would suffer Sayano-Shushenskaya's fate. The disaster also highlighted the dangers of Soviet-era infrastructure. Much of Russia's power grid, its dams, its pipelines, they were built in the Soviet era, 1960s, 70s, 80s. That equipment is now decades old. It is reaching the end of its design life. Without proper maintenance and replacement, failures are inevitable. Sayano-Shushenskaya was a wake-up call, but it was not the only incident. Russia has experienced other infrastructure failures: bridges, buildings, pipelines. The pattern is clear: aging infrastructure, deferred maintenance, catastrophic failure. The human cost of the disaster cannot be overstated. 75 workers, fathers, brothers, sons. They went to work that morning expecting a normal shift. They trusted that the plant was safe, that management would not risk their lives. That trust was betrayed. The turbine had been warning everyone for years. Vibration logs, engineer reports, alarm systems, all ignored. The workers died because management chose production quotas over their safety. The families of the victims were left with trauma that will never fully heal. Some lost primary breadwinners. Others lost loved ones just beginning their careers. The compensation settlements provided financial support, but they did not provide closure. The trials and convictions offered some sense of justice, but the 75 are still gone. The Sayano-Shushenskaya disaster is studied internationally. It is a case study in what happens when maintenance is neglected, when economic pressure overrides safety, when warning signs are ignored. Engineering students learn about it. Safety professionals reference it. The lesson is universal. Infrastructure requires maintenance. Equipment has a lifespan. Ignoring problems does not make them go away. It makes them catastrophic. The memorial at the plant ensures the 75 are not forgotten. Their names are listed. Visitors can pay respects. The memorial is a reminder to workers, to management, to anyone who enters the plant. Safety is not optional. Lives depend on it. The Sayano-Shushenskaya Dam disaster of 2009 remains one of the deadliest hydroelectric plant failures in history. 75 workers died when Turbine Two exploded and flooded the turbine hall in seconds. The turbine had been vibrating dangerously for years. Maintenance logs documented the problem. Engineers recommended repairs. Management chose to keep it running. Production quotas, revenue, profit, all were prioritized over safety. On August 17th, the vibration reached catastrophic levels. The anchor bolts failed. The 2,000-ton turbine disintegrated. Water from the reservoir poured into the hall. 75 workers drowned, crushed, electrocuted, and the disaster was completely preventable. The investigations revealed systematic negligence, deferred maintenance, ignored warnings, equipment pushed beyond safe limits. Criminal charges followed, convictions, prison sentences. But the 75 workers are still gone. Russia rebuilt the plant, installed new turbines, implemented stricter safety regulations, but the memorial remains. 75 names, a permanent reminder of the cost of choosing profit over people. If you want to uncover more stories of global infrastructure hiding dark secrets, subscribe to Hidden Infrastructure. Next time, we will explore the Vajont Dam disaster in Italy, where engineers ignored warnings about an unstable mountain. A massive landslide plunged into the reservoir, creating a wave 250 meters high that overtopped the dam and destroyed villages below. Nearly 2,000 people drowned. The dam itself survived intact, but was never used again. Subscribe now for more hidden infrastructure stories. And remember, the Sayano-Shushenskaya Dam disaster taught the world that vibration warnings are not suggestions, they're alarms. 75 workers paid the price for management's decision to ignore them.